Hello, everyone. We are getting close to being done here. So this is 8.4 video, quadratic functions and their graphs. And in this first part, we're going to take a look at the graph of standard form. Okay, so take notes. 8.4, quadratic functions. So that's degree 2. Quadratic functions and their graphs. Okay, so quadratic function, hopefully you know or are able to recognize one when you see one. Okay, so a quadratic function, we have standard form, and then we have vertex form. Okay, so standard form looks like this. Y equals ax squared plus bx plus c. So some form of this, you usually see it as a trinomial, but it could be a binomial. One of b or c could be 0, but that's standard form. So that's going to be the one that we focus in this first video, and then we'll take a look at vertex form in the second video. Okay, so vertex form looks like this. You've seen this as well, but and we looked at this, how to graph this by shifting, which you can still do. We're going to take a look at another way to graph that aside from shifting. Okay, so let's take a look at the anatomy of a parabola. The parabola is the graph of a quadratic. So just like a line, when you graph a line, there are certain aspects of the line. You know, we look at the slope of a line, we look at the x-intercept of a line, we look at the y-intercept. So same thing here with the anatomy of a parabola. There are certain characteristics that we look at. Okay, so let's go ahead and draw one. So I'm going to go ahead and draw the graph of a parabola. Okay, and here's x, here's y, and suppose that I have a parabola that looks like this. Okay, so we see here that the left is a mirror image of the right, and we have this sort of axis here down the center. So this here is called the axis of symmetry. Okay, and then another very important part is this turning point right here of this parabola. Okay, so over here, this turning point right in there is the vertex. Okay, and that's either at the lowest point of the graph. In this case, it's the lowest point. If it were open the other way, like this, then it would be the highest point of the graph, right? So the vertex is also known as the minimum value if it's like this. And if it's the highest point of the graph, then it's known as the maximum value. Okay, so just keep that in mind. It could be the maximum, it could be the minimum, depending on which way it's open. Okay, so we also have this point right here where the graph crosses the y-axis. And so here, this is the y-intercept. Okay. And then here we have the graph crossing the x-axis here and here. And so we call these the x-intercepts. And there could be 2, there could be 1, there could be none. Okay. And here's another one. Okay, so these are important parts of the parabola. Okay, just put a note here. If a, when you're given something like this, y equals ax squared plus bx plus c. If that a is positive, okay, if a is positive, I'll say greater than 0. Greater than 0 means it's positive. So if a is positive, then your graph will open upward. If a is negative, less than 0 is negative, then your parabola will open downward. Okay? And we can see here that in this case over here, the vertex, the turning point, this vertex would be the minimum value of the graph. And here, the vertex, the turning point over here would be the maximum value. Okay? All right. So let's take a look at graphing standard form. Okay, so we're going to look at standard form, which is that trinomial here, y equals ax squared plus bx plus c. And what happens is all we need is the vertex. In order to graph this, we need the vertex and one other point. And that's pretty much it. You'll get a third point by symmetry, okay? Third point by symmetry. Uh-oh, symmetry is not going to fit. Symmetry. Okay, so the third point we'll get by symmetry. So we need this formula, vertex formula. It's a nice formula because not only does it help us find the vertex, it actually finds two pieces, or it helps find two pieces of the graph here. So the formula I'm about to give you here, first of all, it finds this axis of symmetry. So remember a vertical line, the equation of a vertical line. We have two special case lines. We have a vertical line, and then we have the horizontal line, right? This one is like an x equals like 3, for example. And this one is a y equals a -2, right? So this axis here is like this vertical line. And so the equation of this vertical line, this axis, is going to be some form of x equals some number, okay? So what happens is the formula that I'm going to give you is going to find the axis of symmetry. And we can see here that axis of symmetry is going to be some x value. And it turns out that x value is going to be the same x value of this point, the vertex, okay? So that's why this vertex formula is going to be really handy. So that formula is going to be x equals negative b all over 2a, okay? And remember, that comes from the b and the a that you use come from the equation of the parabola. Okay? So this here finds the axis of symmetry. And it also finds the x value of the vertex. Okay? All right, so let's go ahead and take a look. Let's go ahead and graph y equals x squared minus 2x plus 3. Okay, so we need the vertex. So we're going to be using this formula. And then we're gonna need another point. Okay, here, let me leave the formula there so you can watch. Okay, so the first part, so it's pretty much two parts. Okay, get the vertex. And then part two, get an extra point. And then if you have these two things, then you should be able to graph it. Okay, all right, so the vertex, x equals negative b. And here, a is 1, b is negative 2, and c is 3. So we need b. So b is negative 2. So negative b over 2 times a. And again, here, a is 1, b is negative 2, c is 3. So a is 1. Okay. So we get double negative is positive 2 over 2. 2 over 2 is 1. Okay. Now that is only the x part of the vertex. This is also the axis of symmetry. So we need to find the y value. And so the way we find the y value is by taking this x value 1 and substituting it into this equation to figure out what y is going to equal. Okay, so we want to know what is y when x is 1. Okay, so let's go ahead and do that. Y is equal to, so right now, we only know this part, right, of the vertex. The vertex is a point, and right now we only know the x value. Okay, we need the y value, so I'm going to substitute 1 in for x. So 1 squared minus 2 times 1 plus 3. 1 minus 2 plus 3, and we get 2. Okay, so then my vertex is at 1, 2. Okay, and remember, this is also your axis of symmetry. I'm just going to say axis of sim. Okay. All right, so we need another point, something that's different from 1, 2. The way you get your extra point is going to be random. You get to choose whatever x value you want. The only thing is you cannot choose this x value, because if you choose 1, guess what? You're going to get 2 for your y value, and this is not going to be an extra point. It's going to be the same point. So do not choose the same x value that you have here. Okay. All right. So 0 is always nice. Okay. And yes, you can choose whatever x value you want. You can choose it. Okay. So for this second part, you get to choose the x value. If you want to choose 0, then choose 0. If you want to choose 1.75, then choose 1.75. Okay. You can choose whatever x value you want. Okay. So I will choose 0. And because I can do that in my head. I'll do the work here, but I can do that in my head, which is why I chose it. Okay, so y equals 0 minus 0 plus 3, y equals 3. Okay, but you don't have to show the work here to get this extra point. Okay, all right, so we have our vertex and we have our extra point, so I should be able to graph this parabola. Okay, and I know that because A is positive, this is going to be the kind that opens upward, right? It says here, over here, if A is negative, then it opens downward. A is positive, it opens upward. Okay, so I already know that much. All right, so our axis of symmetry is at x equals 1. And while this is not required or necessary to do the graph of the parabola, I highly recommend that you include your axis of symmetry, because oftentimes when students graph their vertex and this extra point, they mix up which one is the vertex, which one is the extra point, and then the whole graph gets screwed up. Okay, so do this so that you can keep track of the one that's the vertex. So vertex is at 1, 2, which is right here, and I know that one's the vertex because it's on the axis of symmetry. Okay, so that's the vertex. And then I have a point 0, 3. 0, 3. Okay, so I have a point right there. So now we can see how the left half of the parabola. We can see this half, right? Okay, and I had mentioned up here that we would get the third point by symmetry. So we got the vertex, we got one other point, and we get the third point by symmetry. So over here, what I mean is that's the vertex, and this is our extra point. And we see that from the vertex, it's 1 away and 1 up. That's what you're going to have on this side. If you went 1 this way and 1 up, you're going to go 1 this way and 1 up. Okay, so I'm going to go again 1 to the left and 1 up. It has to be the same on this side. So you have to go 1 away and 1 up. Okay, and that's how you get the other half. Okay, when you have the vertex and the extra point, you only get half of your parabola, and you get that third point by symmetry. If this point is 1 unit away from the axis, you'll have one directly across, exactly the same units away. Okay, and we already knew that this parabola was going to be a parabola that opens upward, and we see that it does. Okay, so that's how you graph these quadratics that are written in standard form. Okay, so let's go ahead and let's do another one. Okay, so let's go ahead and graph this one. So let's go ahead and graph y equals x squared plus 4x minus 5. Okay. All right, so first part, we need the vertex. Second part, we need an extra point. Okay, so vertex, x equals negative b over 2a. So up here, b is 4, a is 1. So we get negative 4 over 2, which is negative 2. Okay, so far my vertex is negative 2 something. Okay, now I'm going to go ahead and find the y value. I'm going to take that x value, negative 2, substitute it in here, use parentheses, so especially when you have negative numbers. So y equals negative 2 in parentheses squared plus 4 times negative 2 in parentheses minus 5. So we get 4 minus 8 minus 5. I get negative 4 minus 5. I get negative 9. Okay, so my vertex is at negative 2, negative 9. Okay, and now I need an extra point. Again, I like 0. You can choose for your extra point. You can choose whatever x value you want. Okay, I always get the question, how did you get 0? How'd you get 0, negative 5? How'd you get that? You get to choose. Okay, so I am choosing 0. You can choose whatever you want. We will all get the same graph. Okay, so when x is 0, y is negative 5. Okay, that's why I like choosing 0, because then I can do this in my head. Okay, those of you guys who are like, how'd you get that? All I did was I took the x value that I chose, which is 0, and I plugged it into the equation. I got 0 minus 0 minus 5, which is negative 5. Okay. All right. So now I can graph this and A is positive, so it will still open upward. That's kind of a far way down to go, -9, so I'll kind of draw it a little lopsided like this. That way I can get down to -9, -1, 2, 3, 4, 5, 6, 7, 8, 9. I'll go to 10. -2, -2, -9 is right here. And this is my axis of symmetry. Okay. And then 0, -5. 1, 2, 3, 4, 5. So this time I get the right half of the parabola. Okay. And now to get the other half, well, this point is 2 units away from the axis. So then I'm going to go 2 units away on this side. Okay, so 1, 2. Okay, and there's my parabola. Okay. All right, let's go ahead and take a look at another one. Y equals negative x squared plus 2x minus 4. Okay, so first part, we're going to find the vertex. Second part, we'll find an extra point. Okay, so vertex x equals negative b over 2a. B is positive 2, a is negative 1. So we get -2 over -2 becomes positive 1. So far my vertex is 1 something. Okay, let's find the y value. Let's take that 1 and plug it in. 1 squared plus 2 times 1 minus 4. So here you have to do order of operations. So exponents first, then you can multiply. Okay, right? Order of operations, exponents first, and then multiplication. Okay, so that is going to be -1. So that is -1 plus 2 minus 4. That is going to be 1 minus 4. And that will give us -3. So our vertex is at 1, -3. Okay. All right, extra point. I am going to choose 0 again. When I plug in 0, I get -4. Okay. You don't believe me? Plug in 0. And you get 0 plus 0 minus 4, which is -4. Okay. All right, so now we can go ahead and graph. We have our vertex at 1, -3. 1, 1, 2, 3. 1, -3. And this is our axis of symmetry. The other point is 0, -4. Okay. And we see here that because A is negative, right here, A is -1, it's negative. So we know that the parabola is going to be open downward. And we see that happening here. Okay. And again, we get the other half from symmetry. If this extra point is 1 unit away, then we'll have a point across 1 unit away. And then we can get the other half. Okay. All right. Let's go ahead and try another one. All right, let's go ahead and graph y equals -2x squared plus 4x. Okay, so again, we need the vertex and we need the extra point. Okay, so x equals -b over 2a. B B is 4. So here A is -2. A is -2, B is 4, and C is missing, so C is 0, but we don't use C anyway. All right, so B is 4, and A is -2. So we get -4 over -4, which is +1. Okay, so far my vertex is 1 something. Let's find the y value. Okay, hold on a second. I hope it doesn't update right in the middle. Okay, hold on a second. 1 squared plus 4 times 1. So we get -2 times 1. Got to do the exponent first. Then now you can multiply. And we get 2. Okay. Extra point, I'm going to choose 0. Okay, remember you can't choose this value. So I can't choose 1. So I'll choose 0. When I plug in 0, I actually get 0. I'll let you verify. All right, so 1, 2. That's my vertex. There's my axis of symmetry. I have a point at 0, 0. And because A is negative, it will open downward, right? And we see that happening here. And then by symmetry, I'll get the other half. If I have the extra point right over here, then I will have the third point over here 1 unit away. Okay. So there we go. So that is how you graph standard form of a parabola. Worst case scenario over here, we were getting nice whole numbers for our x value. So when we plugged it in, we only had to plug in an integer. Worst case scenario, you get a decimal. Just use your calculator. If you end up with a decimal or a fraction, just use your calculator to find out what y is. And make sure you use parentheses to group everything. Okay? All right, so that is part 1, graphing standard form. Next video, we're going to take a look at how do you graph vertex form.